So now let's see these two types of OS, okay, multi-programming and multitasking. Okay, so this might sound similar, but the thing is it is different. So let's move on to this. Okay, so first is multiprogramming OS. Okay, so what is multiprogramming OS? In a multiprogramming OS, there are many programs to be executed by a single processor. So there are obviously multiprogramming means there will be different programs which have to be run in the processor. Okay, so the OS will can put the programs in memory, and the OS will pick and start the execution. So there are multiple jobs in the memory, and OS can put one by one jobs, okay, and will start the execution. If we consider some job or program that need input output operation and does not need CPU, okay, so this is very important. So CPU is not needed, so it just needs input output operation and not its CPU. So the CPU can switch to different job. So this, let's say a job A, let's say this A task is only needing input output operation and does not need CPU. Okay, so now the CPU will switch on to some other job, let's say B, which needs CPU. So in this way it is multi-programming. So this is one program, this is another program. So advantages of this multi-programming is, so CPU utilization increases, efficiency obviously will increase, and then throughput will also increase. So these are the advantages of this multiprogramming. So now let's see multitasking. Okay, so multitasking is also called time sharing. Why it is called time sharing? Let's see. Okay, so time sharing or multitasking is logical extension of multiprogramming. It is basically an extension of multiprogramming. Multiple jobs are executed by the CPU switching among themselves. So it is switching among themselves. The CPU scheduler. Okay, so these terms we will use extensive, we will see in our next upcoming videos. What is CPU scheduler? There will be long term scheduler, short time scheduler. Okay, so we will see this. So selects a job from ready queue. Okay, so ready queue you will also see. So it will pick one job from ready queue and switches the CPU to do that job. Here there is a time slot. There will be time slot for that particular job. For each job, when the time slot expired for that particular job, the CPU switches from this job to another job. The switching of the CPU. So it will be given, every job will be given a particular time slot. Okay, some XYZ will be given. Once the time slot is over, the CPU will move on to our next job. So that's why it is called time sharing. Okay, so now why it is called multitasking? Let's see. The switching of CPU among different jobs or tasks, it is so fast that it gives an impression to the user that the user is working with different processor. Okay, so the switching is so fast that it is actually giving us an impression that it is actually doing multitasking kind of thing. Okay, so CPU is shared among different tasks, but it is not, but it gives us an impression because it is very fast. Okay, so again CPU utilization is very good here. And another thing, it is starvation free. Okay, starvation and everything will go in very details, but for now you can see that since it is switching from one job to another, so suppose one job is not eating up all the time. Okay, so it is giving other jobs to use the CPU and it is not starved. So let's say job A is taking particular time, and it is again when the time slot is over, job B will be there. So it is not that only the job A will take up the whole time and job B will starve. Okay, so starvation we will see extensively. For now, just see that starvation is starvation free. So I hope this is understandable because this is important and we might get confused. Okay.